welcome to IGCSE topic 5, the extraction and uses of metals. Some metals, often the most unreactive metals such as gold and platinum, can be found as native metals. That means that you can literally find nuggets or lumps of gold or platinum outside, unreacted, which can be shaped and used straight away. However, most of the metals that we use come from ores. Ores are rocks that contain enough of a metal compound for it to be worth extracting the metal from the rock. Some common ores include bauxite, which contains aluminium oxide from which we can extract aluminium, galena, which we can extract lead, and hemite, which sounds like hemoglobin, which might give you a clue to what's in there. It is iron in the form of iron oxide. Once we have our ore, we now need to work out how we are going to extract the metal from this rock. There are two methods. One of them is the reduction with carbon, and the second is electrolysis. For the reduction of carbon to work, the metal that you're extracting has to be below carbon in the reactivity series. This means that the carbon can displace the metal from its compound, often, for example, iron oxide. It can displace the iron from the iron oxide, leaving iron metal behind and making such things as carbon dioxide. If, however, the metal that you wish to extract is above carbon in the reactivity series, for example aluminium, then you have to use electrolysis to extract the metal. It will not be possible to use carbon, as carbon will not displace metals which are more reactive than it. The extraction of aluminium. Aluminium is extracted from its ore, bauxite, by the process of electrolysis. Bauxite is mainly aluminium oxide. However, the ore itself must be purified to produce a high concentration of aluminium oxide, which can then undergo electrolysis. The aluminium oxide is mixed with cryolite. This acts as a solvent which allows the aluminium oxide to dissolve and also lowers the operating temperature of the electrolysis. This means that there are huge energy savings by having the process run at roughly 950 degrees Celsius rather than at 2000 degrees Celsius. The electrolysis of the molten cryolite with the aluminium oxide dissolved in it take place with graphite anode and cathode. The carbon or graphite anodes are worn away during the process and have to be replaced on a regular basis. At the cathode, molten aluminium is collected. The aluminium ions are attracted towards the negatively charged cathode. The reason that the graphite anodes have to be replaced is that the oxygen which is being formed at the anode will react with the carbon in the anode, forming carbon dioxide gas. So that means that the anode, the carbon anode, the graphite anode, is worn away slowly and therefore has to be replaced. The extraction of aluminium requires huge electrical current. This costs a lot of money to generate and maintain, and therefore the costs are relatively high for the extraction of aluminium from its ore. Aluminium is a fantastic material. It has a low density and brilliant electrical conductivity, which means that it can be used for aircraft bodies, and it can also be used for overhead power cables. Rather than pure aluminium being used, it is often turned into an alloy. This means that the aluminium is mixed with other elements to alter the properties for specific purposes. The non-aluminium atoms in the aluminium metal mean that the layers cannot slide past over each other as easily, and therefore make the metal or the new aluminium alloy harder than the pure metal itself. A very important property of aluminium is that it is corrosion resistant, and the reason for this is that it forms a tough layer, a very thin tough layer, of aluminium oxide over the surface of the metal. This layer prevents the access of oxygen and water to the metal underneath, therefore providing a permanent barrier to the aluminium. This means that when it's used for things like drinks cans, the often acidic drink inside will not corrode the can. The extraction of iron. Iron is extracted from its ore, hemite, which is mainly iron 3 oxide, by using carbon. The extraction takes place inside a blast furnace. Inside the blast furnace are added the following raw materials: iron ore, coke, which is the source of carbon to produce the iron. We've got air, which provides oxygen, and also got limestone, which helps to remove impurities. The first step involves the coke reacting with oxygen, coke being a source of carbon, to produce carbon monoxide. The carbon monoxide then reacts with the iron oxide itself to produce iron and carbon dioxide. The iron oxide is therefore being reduced. Finally, the limestone, which is calcium carbonate, reacts with any of the sandy impurities that might be present in the hematite, for example silicon dioxide, to form a substance called slag, which is a waste material. The coke, the limestone and the hematite containing the iron oxide are fed into the top of the blast furnace. In the bottom of the blast furnace, hot air is blasted in, and in two separate places the molten iron is collected, and in another place floating at the top of the molten iron is the slag, which is also tapped off to be removed. The reason that iron can be extracted in this way is because it's below carbon in the reactivity series, and therefore carbon can displace the iron from the iron oxide, producing iron metal and carbon dioxide. The iron produced in the blast furnace is rarely used as pure iron. Instead, a number of alloys of iron can be produced which have different and important properties. The first alloy is stainless steel, which contains chromium atoms. The new properties of this alloy are that it is corrosion resistant and remains shiny. It's often used for things such as cookware or cutlery. The second alloy is mild steel, which contains a small percentage of carbon. It's hard and strong, it isn't brittle, and it can be shaped very easily, and therefore it is often used in car body panels or building large ships, etc. The final alloy is high carbon steel. This can contain up to about 2% carbon. It is much harder than mild steel and is often used for things such as knives. However, it is brittle, and therefore that's why it's not used for car bodies, as it's not as easy to bend and shape.